Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, this is science sessions for grade 3 and this is chapter 2 lesson 6, what is electrical energy. Again, chapter 2 lesson 6, what is electrical energy, and this is session 1. What is electrical energy? We're gonna talk about the electric or electricity, electrical energy. Okay, so let's watch this video to know more about electric energy.
All matter is made up of small particles that have an electric charge. An electric charge is a tiny amount of energy. The movement of an electric charge from one place to another is called electric current. When this current travels through a controlled path, like wires, it can provide energy to turn on a light or make a TV work. The path a controlled electric current flows through is called a circuit. A circuit must be unbroken with no gaps or a closed.
Okay guys, so let's back to this part again. If you remember, we already said that everything around you is made up of matter. Excellent. And guys, matter consists of small tiny particles like this here. We call it atom, but let's call it now particle. Those small tiny particles have different charges. Positive charge inside it, and outside we have negative charge. Teacher, what the meaning of a charge? We're gonna know after maybe a while. So this is negative. We say it, or if we see this minus, we know this is negative charge, and if we see this plus, we know this is positive charge. Again, negative and positive, negative and positive, negative charge, positive charge. What the meaning of a charge? Electric charge, it's a tiny amount of energy, small amount of energy. Okay, when this electric charge, this positive negative electric charge move from one particle or one atom to another, this causes electricity. Okay, so let's clear those and continue. If you don't get it now, you're gonna get it maybe later in the next video. Okay, so don't rush.
Charge is a tiny amount of energy. The movement of an electric charge from one place to another is called electric current. When this current travels through a controlled path.
Okay guys, let's back to this part. When this is small tiny amount of energy, that which we called electric charge, when the electric charges move from one point to the other point, we call this movement electric current. Again, current, electric current. It's the movement for this electric charge from one point here to the other point. We call it electric current. Good job.
Electric current. When this current travels through a controlled path, like wires, it can provide energy to turn on a light or make a TV work. The path a controlled electric current flows through is called a circuit. A circuit must be
Okay, so let's back to this part again. It's the path, okay, like the road, okay? The path that let electric current move through it, okay? This is electric circuit. It's look like circle, okay? Electric circuit. Again, what the meaning of electric circuit? It's the path, yeah, of the electric charges. Let's look the path of the electric charges. This is electric circuit. Electric circuit. It looked like a circle. Okay, let's continue.
A circuit must be unbroken with no gaps or a closed circuit. For electric current.
Okay, we're gonna talk more about closed and open circuit in the next session. Let's now move to page 73. Okay, and this is electric charge. Let's look here. All matter is made up of small particles that have electric charge. Electric charge. So those small particles, guys, we call it atom. Okay, if you want to know its name, you don't have to say, maybe copy it now, but I just need you to know it's atom. Atom. Again, what is atom? It's this small particle. Small particles, we call it atom. Okay, as you see, this atom have minus, it's negative, plus positive, P and P, plus positive. Here, this is positive charge, okay, if you know, positive charge, and this negative. Positive charge, positive, okay, we write it like this, and this is negative charge. So every particle around you have two kinds of a charge. Negative, here, negative charge, and positive for plus, positive charge. Okay, so let's see, what is the electric charge, positive or negative? What's the electric charge? Electric charge is a property of some particle that cause them attract or repel each other, even if the particles are not touching. Again, it's a tiny amount of energy. Teacher, what's the meaning of this? Okay, let's see. We have here positive charge and negative charge. Do you remember magnet? Okay, like magnet, positive and negative, they attract. Again, positive and negative, they attract. If we have positive here and negative, they are different. Different, like different poles attract. Different charges attract, but the same charges, no, they don't like each other. They repel. Again, repel. Attract if they are different. Repel if they are the same. Positive, positive, or negative and negative. Okay, I hope you got it. If you don't got it, wait. You're gonna see another video. It will show you more, okay? It will help you to know more. Okay, move to the next slide. Watch this video with me to know more about electric charges and electrical energy.
Electricity is all around us, and most of us use it every day. But do you really know what electricity is? To really understand electricity, you first have to start with an atom. Everything in the universe is made up of atoms. Let's look at this ant. We think of ants as being pretty small, but atoms are smaller. Much, much smaller. Atoms are so small, in fact, that one ant is made up of too many atoms to count, more than 1 billion. If you take an object and keep breaking it down to smaller units, eventually you'll be left with only atoms, which we can call the building blocks of everything. Atoms have a couple of different parts, and a really important part of an atom is called an electron. Not all atoms have the same number of electrons. The number of electrons in an atom can change because electrons can move between atoms. Electricity is the movement, or flow of electrons from one atom to another. This flow of electrons is called current, electric current. Electrons can move in all materials, but they can move through some materials better than others.
Okay guys, so let's back to this part here. Those small things here, as you see, they are electric charge. They have electric charge. They have negative electric charge. Negative electric charge. Another negative electric charge. Okay, so this negative electric charge move from this particle or from this atom to this atom and to this atom. So the movement, like here, like this small electric charge. So the movement of those electric charges, we call it electric current. You remember, electric current is the movement of electric charges from one point to another. This is electric current. Okay, let's continue. Yes, okay, I need to continue. Come on. Okay.
If electrons can move quickly and easily in a material, then that material is a conductor.
So guys, here we talk about the materials and how this material help to conduct or let the electricity or electric charge move through it. If we look at this coin, so this coin let electric charge move through it, and this pen too, those made up of metals like here copper and iron, they let electricity move through it. But here, this plastic or paper, this plastic, no, it's insulator. Insulator, this means don't let electricity move through it.
Is an insulator. An insulator is a material that does not let electrons move well and doesn't conduct electricity. Have you ever seen the inside of a wire? The inside is usually made up of copper or another conductive metal, while the outside is made of plastic, an insulator.
Okay, so if we look at the wire, maybe your laptop wire, your TV wire, inside this wire you're gonna find copper. This copper is a metal and it's a conductor. It let the electric charge move through it easily. But here it's insulator, the cover made of plastic, and plastic is insulator. That's why when we touch the plastic cover, nothing happens. But if we touch this copper part, we gonna maybe die. The electric charges maybe shock us. Why? Hurt us. Why? Because electricity is dangerous, and this copper wire here, it's dangerous because it's a conductor. It let electricity move through me, okay? And maybe I'm gonna hurt or die or something. Okay, let's continue.
The copper wire helps the electrons flow, while the plastic insulator helps keep the electricity from being wasted and prevents us from being shocked. To use electric current to power things, you have to create a complete pathway for the electric current to follow. This is called an electric circuit. An electric circuit.
So guys, this is electric circuit. It looked like a circle, but it's circuit. Electric circuit.
Circuit is like a racetrack of conductive materials that let the electrons flow in a specific way.
Yeah, so it's the way or the path, yeah, that electric charges move through it. So this is electric circuit. It have battery. Battery is electric source and those wires and the light bulb. Okay, so let's move to this page 74. Particles have both positive and negative charge. So you see this is P plus positive and negative charge minus negative charge. If it have positive charge equal negative charge, the matter has no overall charge. Teacher, what the meaning of this? Let's see. Okay, if we have here, this is a particle, guys, and we have 5, okay, maybe 5, I'm sorry, it's not good, 5. Yes, now it's a 5. 5 positive charge, okay, and 5 negative charge. This means no one more. They are equal, 5 and 5. So, no one more than the other. So we call it no overall. No overall charge. Okay, if we have positive charge more than negative, like if we have maybe 7 positive charge, okay, and just 2 negative charge, this means this is positive. Yeah, positive overall charge. But if we have 7 negative charge and just 2 positive charge, this means it's negative overall charge. Okay, negative overall charge. I hope you got it, guys. So we look to the number of the charges. If we have positive equal negative, so it's no overall, no one bigger than the other. Okay, I'm sorry. Okay, guys, so now we know charges that are the same cause objects to push away each other. As you see here, they are the same, negative and negative, so repel. Positive and positive, repel. Positive and negative, different charges cause objects to stick together or attract each other, so they attract. Page 75, we talk about electric current and circuit. Electric current is the movement of electrical energy or electric charges from one place to another. Okay, again, the meaning of electric circuit is the movement of electric charges from one point. It's electric current, I'm sorry, electric current, not electric circuit. Electric current is the movement of electrical energy from electric charges or electric charges from one place to another. Let's see, we have here electric charges move from this point to this point, so we have here electric current. Okay, so we have controlled current and uncontrolled current. Controlled current can travel through wires and other materials. Like you see here, controlled current, we can control it, switch it or turn it on, okay? Can be used easily. I can use this easily. Current moving in wire to turn on lamps. As you see, this is an example of a controlled current. Uncontrolled current can travel in any directions, as you see, like lightning, and can't be used easily. It's so dangerous, like lightning. So let's talk about electric circuit. Electric circuit, it's the whole shape here. So this part, this is electric current, and you see here inside the wires electric current, but all this shape, it's electric circuit. Electric circuit is the path, this path, okay, the path that a controlled electric current flows through. Okay guys, let's watch this nice video to know more about electric circuit.
Hello? What's going on, young
I'm sorry guys.
scientist? Hi, I'm trying to make an electric circuit. Electric circuit? Wow! Have you learned that in school? Yeah, a little bit. I have learned that the simplest complete circuit is a piece of wire from one end of a battery to the other. Yes, an electric current can flow in the wire from one end of the battery to the other. But nothing useful happens. The wire just gets hot and the battery goes flat. You are right. To do something useful with electric current, we need to put an electrical component into the circuit, such as a bulb, that can use the current to make something happen. Very good. You already know quite a lot. Now, let's learn some more. When electric charges move in a wire, we say that an electric current flows in the wire. It's like the way a current of water flows in a river. Yeah, it is like a constant flow of electrons through something. When a wire is connected to each end of the battery, electrons begin to flow from negative to positive. Yeah, from minus to plus. And this flow of electrons is called current. Now look at this. Hey, there is no battery in this. Yeah, if there is no battery, no electricity will flow.
Okay guys, so this electric circuit, think with me, it missed something? Yeah, we miss here battery. If there is no battery, so no electricity, no energy, and this will be not electric circuit, no. Okay, so we're gonna complete this video next session, inshallah. Let's now move to answer some questions here. Okay, write the word, no, we're gonna let this to the next session. We just need to answer this question. What happens if two objects with opposite charges are near each other? They're gonna be attract. They will attract. Excellent. Good job. Okay, here let's answer number 6. Matter with more negative charges than positive has an overall negative charge. Yeah, true. And please here try to tell me what's the difference between controlled and uncontrolled current. Good job. Okay, time for new words. Is a property of some particles that cause them attract or repel each other, even if the particles are not touching. And we can call it a tiny amount of energy. Can you tell me? What is it? As you see here, positive and positive repel. Negative and positive attract. So it's electrical charge. Good job. Electrical charge. Positive and negative electrical charge. Okay, look at this picture here. The movement, as you see, the movement of electrical energy from electric charges from one place to another. As you see those blue things moving, it's electric current. Good job, electric current. Number 3,